Hello everyone and welcome in the cybersecurity validation use case. Let me introduce CETIC and SUSE first. The CETIC is an applied research center based in Belgium, and our expertise revolves around artificial intelligence, cybersecurity, optimization, and embedded systems. I don't know if I have to present SUSE, but I do as well. So SUSE is a German multinational open source software company, and one of the first bring Linux to enterprise. And the core experience of SUSE is the enterprise-grade Linux and infrastructure, Kubernetes and container orchestration, and lightweight edge and cloud native solution. So in this validation, cybersecurity validation use case, you will see two different scenarios. The first one is the confidential computing capabilities of the framework and the anomaly detection and edge cluster switching. So let me introduce first the dashboard. So the dashboard shows real-time vehicle tracking, anomaly detection, and edge connection status. So on the top left, you have the event and log section, and this section tracks the onboard device client status, event log, and display the status in an action in real time. And you can also see the device client requirement. The next section is the anomaly detection section, and in this section you can see the anomalies detected by rules and AI and confirmed by AI. In this case is the embedded model for the authentication and geolocation, and the analysis runs in a serverless runtime environment, of course. The next section is the GPS tracker, and in this section you can track the vehicle route from Charleroi in Belgium to Gothenburg in Sweden, and the position and route update are updated in real time. The last section is the vehicle status, and you can show the vehicle connection to the edge nodes, latency and distance change as the vehicle moves. So the first thing is the initialization, and the vehicle start and connect to the COGNIT frontend. The device client is initialized and authenticated and can begin its journey. Now we move on the first step, the confidential computing. And the confidential computing allow function to be executed in a secure enclave, so that is not accessible outside the execution of the environment. So to demonstrate the effectiveness of the confidential computing and the integration of this functionality to the COGNIT framework, we offload and execute a function to assign a simple API key. So the function is offloaded and executed in a serverless runtime. But first, if the function is executed without confidential computing, you can see the confidential is set to no. Then the memory is readable from the host or from it's readable from the host, and you can see the key appears. Now, if the function is executed with the confidential computing, then the memory is not readable from the host. And this allows function to be executed in a secure enclave, so that the data is not accessible outside the environment execution. Now we move on the next step, the next section, the anomaly detection and the edge cluster switching. So the anomaly detection, first the requirement and the function are sent and the vehicle connect to the CETIC edge node. Monitoring and authentication and location can start. First step, the anomaly detection. During the trip, someone tried to connect to the vehicle, and the log is catched and sent as a parameter to the function, which is executed by the serverless runtime, in the serverless runtime. The result is received by the device client, and a first response is provided, blocking a user for a few moments. The anomaly is sent to the embedded model for further analysis and confirmation. And now you can see the embedded model confirm the anomaly. This is for the authentication log anomaly detection. And shortly after, it appears that someone is trying to spoof the GPS signal, and the vehicle seems to indicate that it's in New York. So this is the location is captured again and sent to the serverless as a parameter to the function, which is executed again in a serverless runtime environment using COGNIT. Again, the result is received by the device client and response is provided. In this case, it's a switching of geolocation mechanism. We can see the remediation has corrected the vehicle's position. It can now resume its journey. Now, we move on the next step, the edge cluster switching. As the vehicle gradually moves away from the CETIC edge cluster, it will switch over and connect to the DA edge cluster, Dutch edge cluster. We can see the new edge cluster front-end definition, and the vehicle switch from one edge cluster to another one. Later, during the journey, the vehicle gradually moves away from the DA edge cluster, and now it switch and connect to the Swedish edge cluster. Yes. And now, in this cybersecurity validation use case, we have shown that with COGNIT, you get a secure enclave function execution via confidential computing integration, a resilient execution continuity function across edge cluster, and an integrated detection and remediation for auth and location anomaly. Thank you for watching. Bye-bye.